Hi everyone. This is going to be the second part of us talking about domain and range of a function, how to find it, and let's talk about a couple of more examples. Now I'm not gonna go through what we already did. Let's just continue it with another situation. So let's talk about example 4. Now here the function is going to be g, and g of x is equal to minus 4 times absolute value of 2x minus 3 and plus 5 on a side. Now, of course, now we can talk about two methods. Now let's start with something that's as simple as it gets. Now I want to talk about domain first. We usually talk about domain first. Now what the x's can be. Now domain of function g, as it's simple as it gets. We ask ourselves, is there anything we're not allowed to work with as the x inside of the absolute value? Of course not. We can calculate absolute value of any real number, meaning as simple as it gets, domain of this function g is going to be real set. Set and done. We can continue on. We can move on. Like I already explained for example 3, when we talk about function f, and we also determined that the quadratic function works with all real numbers, there needs to be a sentence where you give me why you concluded that the domain of function g is real set. Now the important thing, and where the issue is when we talk about the range of function g. Of course, we need to define it. Now there is, for this here function, algebraic method. So let's go with the algebra itself. Now I'm going to talk about the concept of absolute value. Now let's talk about the concept of absolute value. Why is the concept of absolute value important? Because this is the actual value that we can determine, and it is going to be part of the function itself. So let's see. So let's start with 2x minus 3, an absolute value of it. Now we should know that absolute value of a number, no matter what is inside, is like 2x minus 3, the absolute value itself is always greater or equal than 0. So we start with that. Now we want to expand it, as we did in example 1 and 2 in past video, so that the whole left side looks like the formula itself. Meaning, first of all, I'm going to multiply with minus 4, sorry. So minus 4 times absolute value 2x minus 3 is going to result or be less or equal to 0 now. Minus 4 times 0 is 0. Last thing we have to do is add 5 to both sides. So minus 4 times 2x minus 3 plus 5 is less or equal to 5. Now the whole left side looks like function g and g of x, so g of x is equal, so less equal to 5. There you go. So now you can determine that g of x is element from minus infinity to 5 included, meaning that range of the function g is equal to minus infinity to 5 included. There we go. So this is the algebraic method. Now, if you want to go with the graphical method, of course you can. So let's talk about graphical method. So let's show it here. I'm not going to make it big. Now, in this method, we have a little bit more to do. We have to be a little bit more precise. Meaning I'm talking about 2x minus 3 as an idea. Now, there are a couple of methods that I've already shown you. Now, let's just go quickly through them to determine what the actual result is. Now, 2x minus 3 is a line. So this is a line. So if I want to represent it, let's start with it. Minus 3 on the y-axis, minus 1, minus 2, minus 3. Of course, 2 is 2 over 1, meaning 1 to the right and 2 upwards. 1, 2 upwards. So we end up in the point here. Here should be 1, sorry. A little bit further to the right. I made it too small for my hands. So here is the 1 itself, not here. So we can draw a line. Of course, I'm gonna not fill it the full line. I'm just gonna mark it so that we know what's going on. And this is the line itself. Now, important thing is before I apply absolute value, I can apply absolute value, meaning the whole part of the negative side of the line is going to become positive, and 0 is still 0. So I can also mark that if I want to. Minus 1, 2, 3. So 3 is the important line. So I can mark that too if I want to. This is the absolute value. This is just the absolute value of 2x minus 3. Now, of course, I want to talk about absolute value that multiplied with minus 4. So what we're going to end up with is something beneath it. Now, what happens with minus 4 or just 4 itself? It is going to narrow down the V shape itself. So it's going to be narrower than the original. So what I can do is just sketch it, of course. Let's mark it like this. So this is the minus 4 times absolute value of 2x minus 3, just as an idea. Now, I'm not actually looking for that. I still have to add 5. So what does this add 5 mean? We have to move it upwards by 5. So we are going to end up with this here point in 5. 3, 4, 5. So we are here. And now I can also make a sketch. So we are starting here. Let's say this is the sketch itself. So this is the graph of function g. So here's the g function. Okay, now why is this important if you want to take a look at graphically? We're just looking at the range. Domain doesn't matter. I don't even care where this point actually is on the x-axis. You can calculate if you need be. But for this range, we don't care. Now, what is important? Well, where do values on the y-axis exist? And they exist in this here interval, starting from 5, not starting from 5, ending in 5, but everything beneath 5, including 5 itself. Now, what did we get in this interval? We are actually working with minus infinity to number 5, and this is the conclusion that we already got. Here you go. Here it is. Now, of course, this method, graphical, unlike methods before, is quite clumsy in a sense that it's cluttered. There is a lot of things here. You can get confused. Even I don't like this method in general just because of this. So probably algebra in this here specific case would be better. Cleaner, everything is visible and easily done. Okay, now let's continue on with the example 5. Couple of more situations. Now example 5 is going to be 2 parts. So let's start with A. Example 5, A. Now, we're talking about M function, and why I want to show you this now. This is going to be combination of already existing functions. Look at this. M of x is equal to minus 4 over square root of 5x minus 3, this is 5x minus 3, plus 2. Why is this a combination? This is a combination of reciprocal and irrational function. Now we also have to determine domain and range of this function. This is what we're asked to find. Well, here we go. Now, first thing I'm going to show you, so there are again 2 methods and you can combine them if you can. Now, first things first is if you want to go with graphical method, are you 100% sure to know how does it look like? In 4th grade, we're going to see how we can find the graphical representation without plotting millions of points and then seeing, well, what works, what doesn't. Some of you might even be able to do it now, but if you can, nice one. If you cannot, do not worry about it. So this means we have to rely on the first method, aka algebra, to determine what's going on. Now let's talk about the domain itself. Now, domain itself is there are 2 conditions basically. First condition, let's start, there is no actual order, so you can start with whatever you want to. So the first condition is that square root of 5x minus 3 has to be different than 0. This is one of the conditions. because we are dividing with square root. So we have to remove the 0 from the whole thing. Now there is also another and it has to be also and, not or, and that is that 5x plus minus 3, sorry, because it is inside of the root, has to be greater or equal to 0. Now, if you want to start with the first here, well, of course, you would square everything, meaning that 5x minus 3 has to be different than 0. Now, you can take a look at both of these situations and see, well, can you combine them? Of course you can. 5x minus 3 is greater or equal to 0. Let's just make it greater. So combination of them two is going to be that 5x minus 3 is just greater than 0. This is the conclusion. So you combine both of these situations into one, and you can do it. Let's add 3 to both sides. So 5x is greater than 3. So divide everything with 5. So x is greater than 3 over 5. And this is the domain. Meaning the domain of this here function is everything from 3 over 5 excluded to plus infinity. This is the conclusion. Okay. Now let's talk about range. Now here is where things, I mean, in this here case are still not that terrible. And what I'm going to start with, instead of going with just square root of as the smallest entity of the formula, let's talk about the fraction itself, and simple fraction that it is. 1 over, you can also start with 4, just so you know. But let's start with 1 over square root of 5x minus 3. And what do you know about this? Same as for any reciprocal function so far. The division between a number and another value will never be equal to 0 if this value that we are dividing is not itself equal to 0, which is not. Now let's expand everything for us to get the m of x. Now there's also one important thing. Is this the only thing that we're talking about? Now this is an important question. Now if you take a look at the root itself, you also have to talk about root itself in all of this. Well, the root itself is always going to be positive value. In this here specific case, it won't be even equal to 0. This means not that just we're talking about difference from 0. We're talking about that if you're dividing positive number with another positive number, we're definitely going to get a value that is greater than 0. So watch out for that. So I started with the assumption that it's different than 0, which is correct, but then I also implemented the root itself. This is an important thing to note. So the starting composition is 1 over square root of 5x minus 3 is greater than 0. Now let's expand stuff. First of all, I'm going to multiply with minus 4. Meaning we're going to get minus 4 over square root of 5x minus 3, and it is going to be less than 0. Then let's add 2 to the both sides, meaning we're going to get minus 4 over square root of 5x minus 3 is going to be, plus 2 is going to be less than 2. Whole left side looks like m of x, so m of x is less than 2, meaning that m of x is element from minus infinity to 2, excluded, and the range of this here function is then minus infinity to 2, excluded. Here you go. And done. Graphical representation, it's quite tricky if you want to go with it 100%. The graph itself looks like this, just so you know, just so you have idea. Here is, let's say here is 2, here is x, y, and it is, here is 3 over 5. This is the curve itself. Just this part of the hyperbola is going to be the actual solution. Now, how I can know this? Well, I determine domain and range and just see what's going on there. Don't worry about the further situations. Now, this was a example. This was quite complicated, the combination. This is last combo. This is one of the hardest, so to say, tasks in written assessment. You can, of course, expect it. Don't worry about it. So let's talk about last sub-example, B. Still example 5. Now for the B, we're talking about n function, where n of x is equal to brackets. Inside of the bracket is 1 over 3x plus 2. Everything plus 10. Close the bracket. Squared plus 5. Another combo of reciprocal and quadratic function. Now, you can complicate stuff if you like. You can actually use the square binom to expand stuff, make a fraction out of all of this, and get lost in all of this. And yeah, good luck with that. But we can immediately start with domain and range, of course, algebraically. Now, domain of n is unknown, range of n is unknown. Now, one thing I have to note, graph of this, I know how it exists, I've checked it. If you ask me now, even I wouldn't draw or do graphical representation. More about it in 4th grade, when we're going to have more methods and tools that we are going to be able to use then, and probably solve it graphically too. But you're gonna see you don't have to work with graph itself. Now let's talk about domain again. We are looking at the x's. Now where the x's are, where we have x's in denominator, part of the division, meaning that 3x plus 2 has to be different than 0. And if I take a greater look at all of this, this is the only thing that I have to watch in all of this. So minus 2, 3x is different than minus 2, divide everything with 3, and x has to be different than minus 2 over 3. This means also that any other real number is perfectly fine. So the domain of this function f are all real numbers apart from minus 2 over 3. Done. So as you can see, domain isn't that big of an issue in general. Basically, we're working with conditions. Now let's talk about the range. Now, range of this is going to be interesting. Now, if I want to talk about the range, I'm going to talk about the smallest entity, which is inside of everything else. If I look at the smallest entity in all of this, this is going to be 1 over 3x plus 2. Now, this is a fraction. So 1 over 3x plus 2 is definitely going to be different than 0. So we're starting with that assumption. Now, first things first, let's add 10 to both of the sides so that we expand and get the whole bracket part, so to say. So plus 10. So 1 over 3x plus 2 plus 10 is definitely different than 10 in all of this. Okay. Now, second thing they have to do, well, the bracket is squared, so the whole expression on the left side, we want to square it. This means we have to square everything. So the whole left side is going to be 1 over 3x plus 2 plus 10 squared is different than 100. Now, here is a tricky part, and this is important step. It's not that when we squared stuff, it's not that we just got that the square has to be different than 100. There is also something else now implemented, and that is the whole square itself, 1 over 3x plus 2 plus 10 squared. Well, it's defined in mathematics. Square of a number is always value that's positive or equal to 0, meaning I have to now add this definition to the whole case. So this is new. So far, we just had one situation. Now we had to expand it because of the squaring. By the way, we didn't have to square so far. So yeah, that was the thing. We didn't have to worry about it. We basically started with the square when we had the situation with the quadratic function. Now we made a quadratic function, meaning we made a rule or made a new definition. Just concluded the definition, sorry. We didn't make it. But we make the square. Now we have to work with the square too. So there are actually two things going on. Both that the square has to be different than 100 and has to be greater or equal to 0. Why did I say and? Well, means that we are working with and between these two situations. They both will work in the end. Let's continue with the starting bit. Now I have to add 5 as the last thing to the both sides, meaning that we're going to get 1 over 3x plus 2 plus 10 squared plus 5 is different than 105, meaning that n of x is different than 105. Now you've shown me here that the value of function n will never be 105. On the other hand, well, we still have to work with the square as greater or equal to 0, just leaving us with plus 5 to add to the both sides. Luckily, no more things to work with. So the whole thing is going to be greater or equal than 5, meaning in this here case, we're working with n of x that is greater or equal to 5. Meaning that n of x is element from 5 included to plus infinity. To plus infinity. Well, we have to work with end. Let's not forget about the end. So what can I say? The range of this function, I'm going to define it here. The range of the function n is this whole interval. And I have to remove 105 from it. Let's remove it. Without 105. And we are done. This is the way you do it. Of course, this type of tasks, the last example, 2 examples that I've shown you, are the hardest ones. They're going to test you in multiple ways. For example, when you square stuff, there is a new thing going on, which we didn't have to work with before. You usually start from the smallest expression, expanding to get the formula itself, and this is how you do it. See ya.